What is mass? Mass is a measurement of how much matter is in an object. Mass is a combination of the total number of atoms, the density of the atoms, and the type of atoms in an object. It is one of the fundamental quantities in physics and the most basic property of matter. We can define mass as the measure of the amount of matter in a body. The SI unit of mass is kg. Note, the mass of a body does not change at any time. Only for certain extreme cases when a huge amount of energy is given or taken from a body. For example, in a nuclear reaction, a tiny amount of matter is converted into a huge amount of energy. This reduces the mass of the substance. How to measure mass? Mass is usually measured in kilograms, which is abbreviated as kg. In physics, there are different ways of determining the quantity of mass. Two of the most commonly used are inertial mass and gravitational mass. Inertial mass is determined by how much the object resists acceleration. For example, if you push two objects under the same conditions with the same amount of force, the object with the lower mass will accelerate faster. Gravitational mass is a measurement of how much gravity an object exerts on other objects. It can also be the measurement of how much gravity an object experiences from another object. What is weight? It is the measure of the force of gravity acting on a body. The formula for weight is given by W equals mg.
As weight is a force, its SI unit is also the same as that of force. SI unit of weight is Newton, N. Looking at the expression of weight, we see that it depends on mass and the acceleration due to gravity. The mass may not change, but the acceleration due to gravity does change from place to place.
To understand this concept, let's take this example. Shape of the Earth is not completely spherical but an oblate spheroid, therefore a person standing at the equator is far away from the center of the Earth than a person standing at the North Pole, as acceleration due to gravity is proportional to the inverse of the square of the distance between two objects. A person standing at the North Pole would experience more weight as he is closer to the center of the Earth than a person standing at the equator. How is weight measured? Following is the formula of a body which has a mass m and weight of magnitude w. W equals mg. So it can be said that the weight of an object is directly proportional to its mass. What is the difference between mass and weight? Weight. Mass can never be zero. Weight can be zero. As in space, if no gravity acts upon an object, its weight becomes zero. Mass is a scalar quantity. It has magnitude. Weight is a vector quantity. It has magnitude and is directed toward the center of the Earth or other gravity well. Mass is commonly measured in kilograms and grams. Weight is commonly measured in newtons. Mass doesn't change according to location. Weight varies according to location. The mass may be measured using an ordinary balance. Weight is measured using a spring balance. How is weight measured? Following is the formula of a body which has a mass m and weight of magnitude w. W equals mg, so it can be said that the weight of an object is directly proportional to its mass. What is the difference between mass and weight? Weight. Mass can never be zero. Weight can be zero. As in space, if no gravity acts upon an object, its weight becomes zero. Mass is a scalar quantity. It has magnitude. Weight is a vector quantity. It has magnitude and is directed toward the center of the Earth or other gravity well. Mass is commonly measured in kilograms and grams. Weight is commonly measured in newtons. Mass doesn't change according to location. Weight varies according to location. The mass may be measured using an ordinary balance. Weight is measured using a spring balance. What is weightlessness? Have you ever been in an elevator? Noticed how you feel like your weight has been reduced while the elevator goes down? That is because the weight you feel is the perceived weight or effective weight. This is the equal and opposite force the floor exerts on you due to your weight. Now if we remove the floor and let you fall freely, there is nothing to exert a force on you and hence you will feel weightless, even though there is acceleration due to gravity and mass. This is because the effective weight is equal to zero. Now let's come back to our elevator. When the elevator is going down, it is actually moving in the direction of the gravity, hence reducing net acceleration due to gravity, thereby reducing your weight. The same happens with astronauts in the International Space Station. As the space stations are orbiting the Earth, it is actually falling towards the Earth indefinitely and everything in it is falling, including the astronauts, so the astronauts experience weightlessness and can float freely around. In all these scenarios, the most important thing we have to notice is that weight can increase or decrease depending on the acceleration due to gravity, but the mass remains unchanged. Relation between weight and mass. Consider a body having large mass and large weight. Example of this situation is a large object which is hard to throw because the weight of this object is large. Therefore, the relation between weight and mass can be derived with the help of Newton's second law, which explains that the free falling object has an acceleration g as the magnitude. If an object with a mass of 1 kilogram falls with an acceleration of 9.8 meters. S2, then the magnitude of the force is given as F equals ma equals 1 kilogram 9.8 meters. S2 equals 9.8 kilograms. M. S minus 2 equals 9.8 n. Therefore, it can be concluded that the relation between weight and mass of an object with 1 kilogram mass will have a weight of 9.8 n. Example: what is the weight of a 50 kilograms mass object? Weight equals 50 kilograms 9.8 meters /S2. Weight equals 490 n. Is mass the same as size? No, mass is different than size or volume. This is because the type of atoms or molecules, as well as their density, helps to determine the mass. For example, a balloon filled with helium will have much less mass than a similar sized item made of solid gold. The law of conservation of mass. The law of conservation of mass states that the mass of a closed system must remain constant over time. This means that although changes are being made to the objects in a system, the overall mass of the system must remain the same. Interesting facts about mass and weight. The word mass comes from the Greek word massa, meaning lump of dough. Scientists estimate that the total mass of the universe is between 1,052 kilograms and 1,053 kilograms. 1,000 kilograms is equal to a metric ton. The Greek philosopher Plato said that weight was the natural tendency of objects to seek their kin. The gravity of Earth can vary as much as 0.5% depending on where you are on Earth. If you weigh 100 pounds on Earth, you would weigh 37.7 pounds on Mars and 236.4 pounds on Jupiter.